Here we go, notes 1.2, simplifying tables and the explicit equation. So this is a new one. All right, so before we start, we're gonna refresh our brains on how to simplify when we see repeating math of the same number. So here we have 3 plus 4, but I'm repeating that plus 4 3 times. So when I show that to simplify, I write times 3 with a parentheses. So in this one, I have 9 minus 2 4 times, so I do 9 minus 2, and then parentheses 4. It's regular sized, it is not an exponent. So whenever you have a lot of addition or subtraction, to simplify it, you use regular sized multiplication. Then we have 3 times 4 a bunch of times. So we do 3 times 4, and we're multiplying by 4 6 times. So when I'm showing repeating multiplication, I use an exponent. So I use an exponent sized 6. Then I have 9 times 1/2. And it looks like that's also 6 times. So I'm gonna do 9 times 1/2, exponent sized 6. Okay, so whenever we see multiplication of a lot of the same number, we use exponents to show how many times. When we see addition or subtraction of the same number a lot of times, we use regular sized multiplication of how many times we added that number or subtracted it. Okay, there's a reason for this. So now we're gonna compare two tables side by side here. So they have the same expanded and the same simplified, and I'll go over that. But the only difference is where they start. So those are the differences here. All right, so let's talk about this first one here. So I have 5, then I have 5 plus 2, then I have 5 plus 2 plus 2, then I have 5 plus 2 plus 2 plus 2. So when I simplify, I have 5 plus 2 times 3, because I have 3 2's. Then I have 5 plus 2 times 2, because I added by 2 twice. Then I have 5 plus 2 times 1, because I added by 2 once. Then I have 5 plus 2 times 0, because I added by 2 0 times, okay? So we already know how to do the recursive equation. For the explicit, we use this simplifying part to help us. So we have the 5, then we have that plus 2, and then this time we just have a regular x because we start at time 0. So that's why it's just an x. So if you want to write a little arrow, it's because we started at time 0 here. Versus our other friend over here. This time, once again, we have that 5, we have that plus 2, but this time we're gonna do x minus 1. All right, so here's the reason. It's because we start at time 1, okay? So let me further explain. So we have an x value of 1, however, our multiplying was a 0. So to get from 1 to 0, we subtract 1. Here, we started with a 2, but we multiplied by a 1. In order for that to be a 1, we have to minus 1, right? 2 minus 1 would give us the 1 here. Then this time we started with 3 in our x value. However, we were multiplying by a 2. So again, I have to minus 1 so that this becomes a 2. This one, we have a 4. However, we start with a 3 inside of our simplifying, so I have to minus that 1. So that is where this x minus 1 comes into play, is because in order for my x values to match with what I multiply by in my simplifications, I have to subtract 1 from those x values. So that's what this is standing for. Let's look at this one. So in the next one here, we are doing 5, then we have 5 times 2, then we have 5 times 2 times 2, then we have 5 times 2 times 2 times 2. So this time we multiplied by 2 3 times, so we have an exponent 3. We multiplied by 2 twice, so we have an exponent 2. We multiplied by 2 once, so we have an exponent 1. We did not multiply by a 2, so we have an exponent 0. So when I write my equation here, I have f of x equals 5 times 2, and for the explicit, I'm going to do an exponent n, okay? And it's just an n because And how will we finish our explicit equation? We just did that with an exponent-sized variable. However, it's just going to be the variable n. Oh, I'm sorry. That was supposed to be an x. That's okay. Just an n because we started at time 0. So let's look at this one. This time we're starting with a -1. However, my exponents do not match these. So we have to figure out. So we got -1, and somehow that has to equal 0. Then we have 0, and that somehow has to equal this 1 exponent. Then we have 1, and that somehow has to equal this 2 exponent. And then we have 2, and we have to do some type of math, so we have a 3 exponent. So think about this. What math can I do right here that I can make it so that I get 0, 1, 2, 3 from these numbers? I can add by 1, right? -1 plus 1 is 0, 0 plus 1 is 1, 1 plus 1 is 2, 2 plus 1 is 3. Okay, so when I write out my explicit, when I finish my explicit equation, it's multiplying. So I'm gonna do regular sized exponent, and let me use the right letter this time because we have x's, so we should keep using x's. But I'm gonna have exponent x plus 1. Okay, these are exponents. We want these to be a +1 because we need to somehow make it so that our x values match with what our simplifying exponents are. Okay? Okay, now we have some examples where we have the table filled out, we have a list, we have images, and then we have a word problem. Okay? I have the expanded section already filled out in these 4 problems, but in your homework, you're gonna have to do the expanded section and then simplify. So let's get started. Let's look at this. So when we simplify, you always want to start at the bottom. It's the best way to know what you start with. So I have a -2, so I'm going to write -2. And that's going to repeat throughout the whole simplifying part of the table, so I'm just going to write that all the way through. Then we see that we're minusing 3. So I'm going to write that -3 all the way through. The last thing we're going to do is count how many times we're minusing 3. So we're minusing 3 times here. So is this going to be regular sized times 3, or is this going to be an exponent 3? This is going to be regular sized because plus or minus, you do a regular sized number. That means this is going to be a regular sized 2 because we minus 3 twice, regular sized 1 because we minus 3 once, regular sized 0 because we minus 3 0 times. Now we're going to write out the recursive equation. So that always starts with f of n equals f of n minus 1. We're minusing by 3. And then our start values are, we have a -1 that we began with. And then we also started with a -2. Okay, remember this is going to be your start time. This is your start number, or another way, first x, first y. Now when I write my explicit equation, we're copying this. So I still use that -2. I have that -3. And then I have a regular sized n. However, I started at time -1. And remember, if we see if it's anything other than time 0, we're going to have to put something in a parentheses with our variable. And I want this to be an x, not an n. Right? Because we have x's. I have to do the opposite of this when I see it in my explicit. So instead of a -1, I'm going to write a +1. Let's look at the next one here. I'm going to pre-fill my recursive equation. So let's start with this one. We are starting with a 26 in our simplifying process, so I'm going to fill that out. And then we're minusing by 6 as we go down. So again, I'm just going to repeat that because that's going to happen no matter what we do. What changes is how many times we minus 6. So in this one, we subtracted 6 3 times, so that's going to be a regular sized. We subtracted 6 twice, so that's regular sized. 6 once, and then we subtracted 6 no times. Again, regular sized. So as I went down my table, right, for my recursive, f of n equals f of n minus 1. My common difference was minus 6. I started with a 1 in my table, so that's my start time. And my start number is that 26. Now let's write the explicit equation. So the explicit equation looks like the simplified version, except we have a variable where we see the numbers changing. So we have 26 minus 6, and then we have n. However, we don't start at time 0, so we have to do n minus 1, because again, we do the opposite in the explicit, okay? So if I have positive 1, we're gonna write a minus 1. All right, so in our image here, it's already filled out. We had at the beginning times 0 with 3 dots, and then it keeps doubling, so that means we're multiplying by 2. So when I start filling out my simplifying, I start with that 3, and notice that 3 is our start time. That's always how you start your simplifying process. And then we are multiplying by 2 as we go down our table. So in our simplifying, we will also show that multiplying 2. So it's always your start time, then your common difference or your common ratio. All right, and then this time we multiplied by 2 3 times. So is that gonna be regular sized 3 or an exponent sized 3? It's gonna be exponent sized. This one was 2 times, so we do an exponent 2, multiplied by 2 once, so it's an exponent 1, multiplied by 2 no times, so that's an exponent 0. So when I start filling out my recursive, we have f of n equals f of n minus 1 times 2. But what's the other way we could write it? And then we started with time 0. So I have f of 0 equals our start number 3, or our first x and our first y. When I write my explicit, I use that simplifying to help me write it. So we have 3 times 2, and then we have the 3, 2, 1, 0 is what keeps changing, so that's going to be my variable n, and it's going to be just an n because we start at time 0, so we don't have to write anything else with that. It's just going to be an n. The last one here, so this time when I start filling out my simplifying, we have 240 is our start number, and we see that going down our table. Also, I can kind of fill in my recursive equation as well. 240 is my start time, so I put that here, and I can start filling out my explicit. Let's see how they all relate to one another. Well, I said that weird. All right, then we're multiplying by 1/2, so I'm gonna write that out in my simplified section. In my recursive, I can write it behind my f of x minus 1. And then we can also write that times 1/2 in my explicit. So that's how these three are related. All right, next up, now we're gonna write our exponents here, right? Because we're multiplying. So we multiply by 1/2 3 times, so I have an exponent 3. Multiply by 1/2 twice, so I have an exponent 1. Multiply by 1/2 once, so I have an exponent, this is an exponent 2, this is an exponent 1, this is gonna be an exponent of 0. Hello. All right, so I start with times 0, so times 0 goes here. And then the start times 0 relates in the explicit equation because my exponent with my 1/2 is just gonna be an n because I start with times 0, okay? So that's how your table is related to your recursive, is related to your explicit equation. All right, if you need more examples, please let me know. I know this was a longer video. It's mostly because we are filling out tables. That's why it makes it so long. But go ahead, do your exit ticket, get started on your homework.